You are listening to The Vocal Technologist. Spoken tech for your ears.
What if the cryptographic locks protecting billions of dollars could be picked in exactly 9 minutes by a computer that sounds, well, like pure science fiction?
It does sound like the premise for a heist film, but I mean, it is a mathematical reality we are barreling towards right now.
I am stepping into the role of your tech-savvy mate for this session, here to help you make sense of it all. If you are a curious professional who wants to understand the mechanics of Web3 without drowning in endless updates, well, you are in the right place.
Spot on.
Our mission on Vocal Technologist is to unpack the most critical developments for those who are smart but, incredibly time poor. We're going to look under the hood of the structural changes that are entirely reshaping the Internet of Value.
And we have a fascinating journey to pull apart. We're going to explore the quantum computing threat to blockchain security, the frankly bizarre new reality of artificial intelligence agents getting their own wallets, how traditional Wall Street giants are quietly rebuilding financial plumbing on-chain, and get into the regulatory turf wars shaping the future of digital assets.
Yeah, let's get right into this first major threat, because I think we need to begin with an existential problem facing the underlying maths of cryptocurrency.
We do.
There is a joint paper from Google, the Ethereum Foundation, and researchers at Stanford that completely blew my mind. They demonstrated that certain private keys, specifically the elliptic curve signatures that secure most crypto, they can be recovered in roughly 9 minutes.
9 minutes is the benchmark they hit, yes.
9 minutes. And they do this using a small number of logical qubits. Can you explain the mechanics here? Because I reckon a lot of people, myself included, assume quantum computers are still decades away. What exactly is an elliptic curve signature, and why is a quantum computer so good at breaking it?
To understand the threat, we really have to understand the lock. An elliptic curve signature is essentially a mathematical trapdoor.
Right.
It relies on the fact that classical computers are terrible at factoring massive numbers or solving specific geometric equations. If you want to drop down the trapdoor to verify a transaction, it is instant and easy.
But climbing back up is the hard part.
Exactly. If a hacker wants to climb back up that trapdoor to figure out your private key from your public data, a standard supercomputer would need, well, millions of years to guess the right path.
So normal computers have to check every single possibility one by one. It is sort of like trying every combination on a padlock that has 1 trillion dials.
That is a great way to put it. But quantum computers do not pick the lock by trying every combination. Instead of processing ones and zeros sequentially, they use qubits.
And qubits can exist in multiple states at once, right?
Yes. They run specific algorithms that essentially calculate the exact shape of the trapdoor instantly. They map the underlying structure of the math, find the hidden pattern, and extract the private key in minutes.
Okay, but I read that qubits are incredibly fragile. Like, a slight change in temperature or a stray electromagnetic wave completely ruins their calculation. So how on earth did this research team get around that?
Well, that is where the distinction between physical and logical qubits comes in. You mentioned they used a small number of logical qubits.
Right. What is the difference there?
That is the core breakthrough. Historically, quantum computers have been incredibly error-prone. You needed millions of physical qubits just to correct the errors enough to form a few stable, reliable, logical qubits.
Oh, okay.
Think of a logical qubit as a single dependable worker, but you need 1,000 highly distracted physical workers double-checking each other to produce that one reliable result.
That makes heaps of sense.
But the hardware is accelerating much faster than anticipated. A startup named Oratomic used neutral atom research to dramatically cut the physical qubit requirements.
Wait, neutral atom research, what does that actually mean in practice? Like, how does that work?
They are essentially using highly focused lasers to suspend individual uncharged atoms in a perfect vacuum.
Oh, wow.
Because the atoms are neutral, they do not repel each other, and because they are suspended in lasers, they are completely isolated from environmental interference.
So they do not get distracted, to use your worker analogy.
Precisely. By doing this, Oratomic dropped the requirement from over 100,000 physical qubits down to just 19,000.
That is massive.
That compounding leap in hardware efficiency means the timeline for a machine capable of cracking these signatures is shrinking rapidly.
Yeah.
I mean, Google has already moved its internal post-quantum cryptography deadlines forward to reflect this urgency.
I have to admit, hearing that makes me incredibly nervous. Is this like finding out the steel vault we all trusted is suddenly made of wet cardboard?
The vault is still steel right now, but we can see the rust accelerating, and we know the precise math required to break the structure. The cryptographic industry has moved entirely from abstract concern to active defense.
Which forces massive architectural changes across every blockchain, I imagine.
It absolutely does.
And it seems like different networks are taking very different approaches to patching this wet cardboard vault. Ethereum is preparing by integrating post-quantum signature schemes into their architectural upgrades, specifically something called Lean VM. But Bitcoin is facing a really contentious path. They have proposals for gradual migration and another concept called hourglass to restrict spending of vulnerable coins. Why is Bitcoin struggling with this while Ethereum just rolls out an update?
Ethereum has a culture of executing hard forks to upgrade its infrastructure. So pivoting to post-quantum cryptography is treated as an engineering priority. They just push the code.
And Bitcoin is the opposite of that.
Completely. Bitcoin, by design, resists change to protect its core properties as hard money. You have a massive network of miners and node operators who are philosophically opposed to altering the foundational rules.
Right, because if you can change the rules for the cryptography, someone might try to change the rule about there only ever being 21 million Bitcoin.
Exactly. It is a slippery slope for them. But if consensus stalls, roughly 1 million early Bitcoin could be exposed to theft.
And that includes the original holdings of the pseudonymous creator, Satoshi Nakamoto, right?
Yeah, it does. Those early coins use an older, much more vulnerable public key format. Deciding how to protect those dormant coins without violating the core tenets of the network is arguably the most difficult philosophical challenge Bitcoin has ever faced.
So the takeaway here is that the maths isn't broken yet, but the stopwatch has officially started, and it is turning into a massive governance test.
Spot on.
But we just talked about how algorithms might break our current security. Let's look at the flip side. What happens when those algorithms aren't trying to break the vault, but are actually opening their own bank accounts?
That is where things get really interesting.
Because autonomous artificial intelligence agents are the very strange new customers walking through the front door. We are seeing the launch of the Buy 402 Foundation. This involves massive traditional finance players and major tech companies establishing a neutral open protocol for machine-to-machine payments.
Yes.
Why on earth do machines need their own payment protocol? Like, why can't an AI just use Visa?
We have to look at how the internet operates for you and me. Our payment rails are entirely built around human identity and manual authorization.
Right, the friction we are used to.
You enter a credit card number, you receive a text message, you click approve. An artificial intelligence agent cannot do that. It does not have a passport, a social security number, or a smartphone to receive a two-factor authentication text.
Ah, I see. So the legacy systems are essentially filtering them out by default.
Yes, they are. Projections suggest the machine economy will drive hundreds of billions in commerce, with agents handling everyday tasks. Imagine an AI negotiating server space, paying for API calls, or executing trades on your behalf.
I need to move fast.
They need a settlement layer that operates programmatically with instant finality across both fiat and crypto rails without a central authority throttling access. Blockchains are native to the internet. They run on public-private key pairs, which a machine can generate and manage instantly.
And we are already seeing this move from theory to practice. There is a platform called RoboNet that launched a prompt-to-quant engine. It literally turns natural language into complex trading strategies.
That is a fascinating tool.
You type in what you want, it backtests the strategy against years of market data using advanced risk metrics, optimizes the parameters, and then deploys it as an autonomous on-chain vault. But here is where it gets properly weird.
Okay.
There is another platform called Ask Gina that has processed millions in volume, and their crucial finding was that large language models are actually terrible at precise financial maths.
It is a brilliant engineering insight when you pull apart how these models actually work. Large language models like ChatGPT are probabilistic text generators. They do not calculate.
Wait, really?
Yes, they basically just predict the next most likely token based on their training data.
So if I ask it to calculate 5% of a heavily leveraged $1 million portfolio, it is not actually doing the maths. It is just guessing what numbers usually follow that kind of sentence.
Exactly. It is highly sophisticated autocomplete. If you ask a large language model to calculate a precise basis point position size under extreme leverage, it will confidently hallucinate the wrong number.
Oh, that is terrifying.
It will give you a beautifully formatted, completely incorrect answer. That is catastrophic when real money is involved.
So how do they fix it if the AI is fundamentally bad at maths?
Developers have shifted their architecture. They force the AI to write deterministic code instead of computing outputs directly.
Ah,
They
okay.
separate the intelligence from the execution. You tell the agent what you want. The AI writes a Python script or a smart contract designed to calculate 5% of your portfolio. Then, traditional deterministic software executes that code.
So the AI builds the calculator, it does not do the calculation itself.
Spot on.
Because apparently that is where we are now, trusting algorithms with the company credit card. It sounds like sending a toddler to the shops, but you have to write them an incredibly specific, unbreakable instruction manual first so they don't spend the entire budget on lollies.
That captures the dynamic perfectly. And that is why infrastructure like Ampersand is being launched. It allows these agents to hold balances and spend, but within very strict, mathematically enforced budgets.
Right.
The value in this new ecosystem will not just accrue to the agents themselves. Raw agent intelligence will eventually commoditize as open source models improve. The real value will concentrate in the choke points.
Which are what exactly?
The interface where you set your intent, the payment rails the agents run on, and the compute layers powering their logic. Multi-rail orchestration and stablecoins are essential here because they allow machines to natively hold and transfer value globally.
Oh, but hang on. While the machines are building this futuristic economy, the traditional financial institutions are quietly buying up and rebuilding the foundational plumbing of the entire space.
They certainly are.
If you are wondering why every major bank is suddenly interested in blockchain, the volume numbers are staggering. Stablecoins have processed tens of trillions of dollars, officially surpassing the volume of major traditional credit card networks like Visa and MasterCard.
When you move that much value, you need institutional-grade infrastructure. Take the Better Money Company, which raised significant capital to build a stablecoin clearinghouse. Right. Historically, we had immense fragmentation. You had different blockchains, different stablecoin issuers, and moving value between them was clunky and carried massive slippage risks.
Slippage meaning the price slightly changes while you are trying to make the trade, right? So you end up losing fractions of a cent on every dollar, which adds up to millions when institutions are trading.
Correct. This new clearinghouse is designed to let any supported stablecoin settle at par through a single integration. It actually mirrors the bank clearinghouses of the 19th century.
How so?
Back then, private banks issued their own paper notes, and merchants had to figure out if a note from a bank in New York was worth the same as a note from a bank in Boston. Clearinghouses stepped in to standardize the value and settle the debt centrally. We are seeing history repeat itself in code.
And the traditional giants are absolutely moving on-chain. We have tokenized U.S. Treasuries gaining serious traction, the New York Stock Exchange announcing continuous 24/7 equities settlement platforms.
Yes.
European giants like BNP Paribas are launching crypto exchange-traded notes for their retail clients in France. The lending stack is entirely flipping from vertical monolithic banks to modular horizontal layers.
It is a total architectural shift.
But I have to push back here. If we are just rebuilding the traditional banking system on a blockchain, complete with all the old clearinghouses and regulations, aren't we just recreating the exact same choke points with new code? Where we're just handing the keys back to Wall Street?
You are identifying a very real tension in the market right now. The short answer is yes, we are recreating choke points, but the mechanics are fundamentally different.
Okay, untack that for me.
The legacy financial system is a monolith. A single bank originates your loan, holds your deposit, manages the compliance, and processes the settlement. They own the entire vertical stack, which makes them slow and expensive. What blockchain enables is a modular horizontal stack. One protocol handles your identity, another handles the liquidity pool, another executes the settlement.
So it is like breaking up a massive, slow-moving monopoly into a bunch of hyper-efficient competing apps that all talk to each other perfectly.
Exactly. However, the winners in this rebundling will still be the companies that own the unskippable choke points. If you control the premier stablecoin clearinghouse or the trusted compliance layer for tokenized treasuries, you hold immense power. You get to clip the ticket on every transaction.
And the regulators are acutely aware of this power dynamic. Federal Reserve Governor Michael Barr has been pushing for strong oversight, and he specifically warned about the structural threat to fractional reserve banking.
That is a critical point.
I really want to pull this apart for the listener because it explains so much of the regulatory friction we are seeing. If dollars migrate entirely out of traditional bank accounts and into fully reserved stablecoins that only buy U.S. Treasuries, what actually happens to the banks?
Let's walk through the mechanism. Fractional reserve banking relies entirely on your deposits. You deposit $100 into your local bank.
Yep.
The bank keeps a fraction, say $10, in reserve, and lends the other $90 out to fund your neighbor's mortgage or a small business loan. That is how credit is created in the economy.
Right. The money isn't just sitting in a vault. It is actively moving around, generating economic activity.
Now, stablecoins operate differently. When you buy $100 of a fully reserved stablecoin, the issuer takes your fiat money and buys a highly liquid government treasury, holding it 1-to-1.
They just sit on it.
Exactly. They do not lend it out to a small business. They just sit on the treasury and collect the yield.
So the money is safer, but it is completely isolated from the real-world credit market.
Yes. So if corporate treasuries and retail users realize they can get better yields and faster payments with stablecoins, they will move massive amounts of capital out of traditional bank accounts.
Which starves the banks.
Precisely. If traditional banks lose their deposit base, private credit creation constricts. Smaller banks lose their lending capacity entirely. Mortgages get more expensive. Business loans dry up. It is a genuine macroeconomic threat to how credit functions in the traditional economy.
That makes total sense. If you pull the deposits out of foundation, the whole house of cards starts to sway. Which explains why this collision between traditional finance and crypto brings inevitable friction, and it is leading to a massive cleanup of the industry's Wild West tendencies.
You're definitely seeing a cleanup.
We are watching Bitcoin's parabolic growth era seemingly come to an end. It is transitioning into a macro-sensitive asset with compressing returns, largely driven by massive institutional ownership through ETFs. The days of seeing 1,000% return in a few months seem to be fading.
The market cap is simply too large now to support those exponential moves. It takes billions of dollars in fresh capital just to move the price a few percentage points. It behaves much more like a large cap equity.
And as the institutional capital has grown, so has the regulatory enforcement. And we are seeing massive legal and political moves on that front. The U.S. indicted 10 executives from international market-making firms for wash trading. For you listening, wash trading is essentially when an entity trades an asset back and forth with itself to create fake volume, tricking regular retail investors into thinking a coin is highly popular.
It is a classic manipulation tactic.
The FBI physically baited these executives in an undercover sting, creating their own token to catch the market makers artificially inflating the price.
It is a remarkable escalation in enforcement. And meanwhile, Canada is proposing a total ban on crypto political donations in their federal election system, citing tracing difficulties.
Conversely, U.S. politicians are actively exploring a strategic Bitcoin reserve and establishing domestic mining certification to secure hash rate. Now, I want to be very clear here for you listening. We are never going to take political sides on this show.
Right, we are just looking at the mechanics.
Exactly. We are impartially reporting on these developments to highlight the sheer scale of the legislative proposals currently on the table. But the contrast is wild. One country is trying to ban it from their political system entirely, and another is discussing stockpiling it like gold.
The contrast between jurisdictions is stark, but the underlying theme is identical. State actors are asserting control. The era of permissionless experimentation is colliding with sovereign law. We see this extending into the prediction market arena as well.
Yes, the prediction markets are fascinating right now. Washington State is actively suing Kalshi over allegations of operating illegal gambling products. This is triggering a massive jurisdictional battle between state authorities and federal regulators over what constitutes a financial derivative versus a bet.
And it is not just the regulators getting involved.
Oh.
The National Football League sent letters pushing for tighter rules on prediction markets, specifically targeting easily manipulated events. They do not want people betting on announcer commentary or celebrity attendance or things that a single person could influence.
Yeah, that makes sense.
Meanwhile, Polymarket, the giant in the prediction space, is expanding its fee structures to capture revenue from this explosion in trading volume.
It makes sense from their side. They spent years acquiring users, and now they are flipping the switch to aggressive monetization. But I think it is important to note that the internal mechanisms of decentralized finance are also facing their own painful maturation process, specifically regarding tokenomics and security.
Very true.
It is not just external regulators forcing them to grow up. Their own internal designs are breaking under pressure.
Yes, let's look at the structural failures. There was a very popular economic model called vote escrow tokenomics, often abbreviated to V-tokenomics.
Right.
Major protocols like Pendle, PancakeSwap, and Balancer heavily relied on it, but they've all abandoned it.
What actually broke there? Because I remember reading about vote escrow tokenomics a few years ago, and everyone praised it as the ultimate solution to align user incentives.
Well, the theory was elegant. If users locked up their tokens for a long period, they would earn voting power. That voting power gave them the right to direct where the protocol distributed its daily yield payouts.
So it was supposed to encourage long-term thinking.
Supposed to, yes. In practice, it led to massive whale manipulation.
How exactly did they manipulate it?
Massive entities accumulated enough voting power to route protocol emissions into completely unprofitable, obscure liquidity pools that they completely controlled. They were essentially voting to pay themselves the protocol's treasury reserves.
That is incredibly dodgy.
It failed fundamentally because capital's mercenary. All these major platforms have been forced to pivot to deflationary mechanics, choosing simple algorithmic buybacks and fee berms over complex voting systems. They realize that simple and secure is better than complex and exploitable.
And speaking of exploitable, we have to talk about the massive Drift protocol hack. It was a decentralized exchange hit for nearly $285 million. But when I read the postmortem, I let out a very self-deprecating sigh.
Oh, why is that?
Because it is never the complex maths that fails, is it? It is always a human leaving the admin keys under the digital doormat.
It is the ultimate irony of the space. Forensic analysis attributed the breach entirely to compromised admin keys. There was absolutely no flaw in the smart contract mathematics.
None.
None. The smart contract performed exactly as it was coded to perform. The attacker simply gained access to the human privileges required to drain the vaults.
It highlights a critical vulnerability that I reckon a lot of people overlook. You can build the most mathematically secure, heavily audited protocol in the world. But if the private keys controlling the upgrade functions or the treasury are stored poorly by a human operator, the entire system is completely compromised.
It proves that decentralization is a spectrum. If a protocol has an admin key that can unilaterally drain funds, it does not matter how advanced the cryptography is. The human is the weakest link.
Which makes me wonder, between the human errors, the intense legal crackdowns, the whales manipulating governance, and the compressing market returns, is the era of massive exponential crypto returns permanently over now that the adults have firmly entered the room?
I do not believe the innovation is over, but the nature of the space is undeniably shifting. What we are witnessing is an industry shedding its highly speculative skin to become foundational global infrastructure. You can see this maturation in legal frameworks as well.
What?
Alabama just passed a landmark bill granting formal legal recognition to decentralized autonomous organizations.
Wait, Alabama, that is not the state I would have guessed is leading the charge on decentralized corporate law?
It is surprising, but they're giving DAOs full legal personality, liability protection, and a clear path to tax compliance. They can enter contracts and own property just like an LLC.
Wow.
When state governments are writing bespoke corporate law for decentralized protocols, you are no longer in the fringes of the internet. You are integrating directly with the core operating system of global commerce.
So the takeaway for that segment is that crypto isn't dying. It is just putting on a suit and getting a desk job.
That is a brilliant way to phrase it.
That is an incredible synthesis of everything we've covered. The sheer scale of the shift is breathtaking. We started by unpacking how the very mathematical foundations of the blockchain have to be quantum-proof to survive the next decade of supercomputing, shifting from fragile physical qubits to lasers suspending neutral atoms.
We then explored how artificial intelligence agents are being given their own wallets, forcing developers to make AI write deterministic code rather than relying on probabilistic guesses.
We saw traditional Wall Street giants quietly swallowing the underlying plumbing, and how the massive migration to stablecoins poses a literal existential threat to traditional fractional reserve banking.
And finally, we pulled apart how the entire sector is navigating intense regulatory turf wars, from FBI wash trading stings to the painful internal maturation of failed tokenomics and compromised admin keys. It is a phenomenal amount of change occurring simultaneously across hardware, software, and international law.
It really is. Thank you for joining me on Vocal Technologist to explore these massive shifts. Hopefully you feel a little more equipped to navigate this strange new reality.
It has been a great chat.
But before you go, I want to leave you with one final thought to mull over. If autonomous agents eventually become the primary users of on-chain finance, executing millions of microtransactions a second based on complex algorithmic logic, will human design interfaces and traditional financial regulations even matter? Or will the machines simply build an entirely parallel, self-sustaining shadow economy in the dark, entirely outside our line of sight? Keep thinking on that one.
Spoken Tech for your ears.